Okay, welcome to those who are confused and would like some extra help with the earthquakes and epicenters activity that we started on February 20th. And to those of you who are maybe gone on the 19th and didn't start with the rest of us. So, what we're doing here, our goal is to find the epicenter and magnitude of a specific earthquake. In order to do this, remember that we will need 3 separate stations to triangulate the exact epicenter of our earthquake. So the first thing we're going to need to do is find the SP interval of the Eureka station, Elko station, and Las Vegas station. In order to do this, you will need your earthquake data packet. It looks like this and starts with seismograph station data for Eureka, Elko, and then Las Vegas. So we're going to do this first one together, Eureka. Here, in order to find the SP interval, you need to look at the primary wave, which starts here. It's the smaller wave and comes first. Then we'll need to look at the secondary wave, which is larger and comes second, hence secondary. So here, our primary wave, if I look at exactly where this wave starts, so the first bit of movement right here, I can trace this down and I see that this wave starts at 0 seconds, okay? So I'm going to go back into my data sheet and I'm going to plug in that my P wave is 0 seconds. Then I'm going to come back to my graph and I'm going to look at the S wave. So here I'm going to look at the very start movement or the very beginning movement of my S wave. And you can see this little line right here. It kind of falls right between this last blue line before 50 and then the 50 mark. Because these blue lines go up by 2, we're going to call the start of the S wave 49 seconds. So here, I can come back in my data sheet and I'll say S is equal to 49 seconds. Now here I'm going to do a little bit of math. This is a secret equation here. So we have S 49 minus P 0, which looks like this. 49 minus 0 equals, and here that's pretty simple, just 49 seconds, right? Now that I have my SP interval, which is a time measurement, I need to find how far away this earthquake is from the Eureka station. In order to do this, I'm going to go back into my data packet and I'm going to go to the second page in where I see the SP interval time graph. Here I have a graph that graphs my time in seconds by distance in kilometers. So because my SP interval for Eureka was 49 seconds, I'm going to plot 49 seconds on the Y of my graph here. So here's 50, 49 is just one under that. What I'm going to do is I'm going to trace this blue line horizontally till I hit my SP line, this black diagonal line here. So when I trace this over and I hit the black line, I'm going to follow this downward until I see distance in kilometers. So here I'm in this second to last blue, the last blue line before the 500 mark. And since there's 4 blue lines between 400 and 500, I know each of them go up by 20. So this last one here should be 480 kilometers. So I'll come back in my data sheet and I'm going to plug in 480 kilometers. Now, I cannot find the epicenter or the nearest city to my epicenter with just the data I have right now. Remember, we have to use triangulation to figure out the epicenter. So I'm going to need data from my other two seismic stations in order to figure out the epicenter. So your next job is going to be to find the SP interval for Elko and the SP interval for Las Vegas, and then both of their distances from the epicenter. Once I have this information, I can begin plotting it on a map. So on the back of your second page of your data table, you will have a map that looks like this. You'll see you have the Eureka station, the Elko station, and your Las Vegas station on this map. You also notice you have a key down here. Now, what we're going to need to do is draw a circle around each of our stations that measures the distance that station is from the epicenter. So, for example, we know Eureka Station is 480 kilometers away from the epicenter. So we need to draw a perfect circle at 480 kilometers from Eureka. In order to do this, we're going to need to use our key down here. You'll notice that this key only goes up to 400 kilometers. So you're going to need to extend the key outward or draw a line outward from 400 kilometers to add an additional probably 300 kilometers more. In order to do this, if you measure the distance between 0 and 100 kilometers, you'll find that it's a ½ inch. So if we take our ruler and put 0 at 400, we can make a tick mark at a ½ inch. That will make 500. And then another tick mark at 1 inch, which will be 600. And then another tick mark at 1.5 inches, which will be 700 kilometers. From there, we can take our compass, which you should have available to you in class, and stretch the compass, so the point between the needle point and your pencil, between 0 and 480, which should be just about here. So you want to, again, stretch the needle point or the pointy end of your compass from there, from 0, and then the pencil end should be over here at about 480. Once you have that measurement ready on your compass, you're going to put the pointy end on your Eureka station and then gently lay the pencil down and trace a circle around Eureka at 480 kilometers. This should give you a perfect circle around Eureka. Then you'll do the same thing for Elko and Las Vegas. Where those three circles intersect should give you your epicenter, okay? You'll just need to find the closest city to that epicenter. Once we've found the epicenter, we're on to part 2, which is probably where a lot of people who were here on the 19th are ready to get started. So for part 2, we're looking for the magnitude of our earthquake. In order to find the magnitude of our earthquake, we're going to need to go back to our seismographs. So those are the first graphs from Eureka, Elko, and Las Vegas at the beginning. Here we're looking at amplitude. Your amplitude is read on the Y of your graph. Now you'll notice that the amplitude starts at 0 in the middle and goes upward in numbers on the top and on the bottom. These are equal both on the top and the bottom. So it doesn't really matter if you look at the top or the bottom, it'll give you the same number. So here for Eureka, we're going to measure the tallest point of our S wave because that's always going to be the biggest wave. So you'll notice here that each of these lines goes up by 10. So here our S wave reaches the last blue line above 250. So that's going to give us 290. Okay, and that's in millimeters. So we can come back into our data table and plug in 290 millimeters. Okay. Now, you're going to want to do that for your other two stations, Elko and Las Vegas as well. From there, once you have the amplitude for each of your stations, you're going to go back into your data packet and go all the way to the bottom where you see your nonogram. Okay, your nonogram is going to help you find the magnitude, which is displayed in the middle. It's the middle line here. You'll notice you have distance in kilometers on the left and amplitude in millimeters on the right. So in order to do this, we're going to find our distance, or we're going to plot our distance that we already found. Okay, so our distance for Eureka was 480 kilometers. So here we're going to find 480. So here's 400. Each of these little tick marks between 400 and 500 go up by 20. So here our 480 mark is the last tick mark before 500. Then we're going to plot our amplitude. So here we need to look at our amplitude, which was 290 millimeters. Okay. So if we look here, our amplitude on the right side is a little weird between 200 and 500. This tick mark here is actually 300, and then this tick mark here is 400, and then we have 500 at the top. So 290 is actually going to be just a little, like a hair beneath 300. So you can make a little tick mark there. Then you're going to take your ruler and draw a line from 290 to your 480 kilometer mark on your distance. So from here to here. Where that line crosses this middle line is your magnitude. You can figure out the magnitude by just plotting one of your stations. However, you're going to want to check your work with the other two stations to make sure that you're correct. Once you do, you're going to find where all three cross on this line, and you can write your answer here. If for whatever reason you have one or two that do not cross at the same spot, you probably made a mistake and you need to go back and check your work. Okay? Once you're done with your magnitude, you have everything you need to help you answer questions about the MMI scale. So that's question 1 and 2 here. And then the rest of the questions on the back would just analyze the type of plate boundary you have and what's going on there to create this kind of earthquake. Once you're done, make sure you turn this in. It is due on the 20th, and then you can start on your Chasing Quakes reading.